This is Chapter 8, Kinetic Model of Matter. There are 3 learning outcomes for this chapter. The very first one, LOA, we're going to compare the properties of solid, liquids, and gases. The second LO, we're going to look at the molecular structure of solid, liquid, and gases. Specifically, we're going to look at how the forces, the distances, and the motion of these molecules will explain the properties of the solid, liquid, and gases. The third LO, we're going to look at the relationship between the motion of the molecules with temperature. Kinetic model of matter states that all matter is made up of tiny particles called atoms or molecules. And these particles are always in continuous random motion. So when do you use particles? When do you use molecules in your explanation? The answer is refer to the question. So if the question states using molecules, then you use molecules. Now, one very important thing is that for you to take note is there are so many molecules in a solid, liquid, or gas. So use average speed, use average distance to describe. Because the individual molecules have very different distances, have very different speeds. Now, it is important for you to write molecules in a solid, molecules in a liquid, molecules in a gas, rather than using the word solid molecules, liquid molecules, gas molecules, because they are all the same molecules. In describing the molecular structure of a solid, liquid, or gas, we are going to look at 3 things. Number 1, the arrangement, the motion, and the intermolecular forces of attraction. And we're going to use this to explain the properties of a solid, liquid, or gas. So, for example, why does a solid has fixed shape? And the reason why solid has fixed shape is because they are closely packed with irregular pattern. They vibrate only about fixed position, helped by very strong intermolecular forces of attraction. Therefore, a solid has fixed shape. Why is a solid incompressible? It is incompressible because the molecules in a solid are closely packed with very little space in between. Therefore, they cannot be compressed. So it is important that you know the arrangement, the motion, and the intermolecular forces of attraction for solid, liquid, and gases to explain these properties of the solid, liquid, or gas. Right. Now, moving from a solid to a liquid to a gas, the average distance between the molecules will increase, the average speed of molecules will increase, and therefore the average Ke, the average kinetic energy of the molecules will also increase. And the intermolecular forces of attraction decreases as you go from solid to liquid to gas. Brownian motion refers to the random motion of particles such as pollen, dust that are suspended in fluids. Brownian motion was provided the initial evidence of the presence of tiny particles in the air. Alright, now why do these pollen grains, pollen particles move randomly? So if you look at a simulation, so if you imagine the yellow particle, this yellow particle as a pollen, you can see that it moves randomly in different directions. And the reason is because there are numerous air or water molecules moving around randomly at high speeds. And they collide with the larger smoke particle or the pollen particles. And when they collide, these collisions will produce a resultant force. This resultant force changes depending on the number of collisions. So the resultant force will have varying magnitude and varying direction. And this causes the particles to move randomly. So if you're asked to draw a molecule with Brownian motion, so you're going to draw something like that. Okay. Let's look at the effect of temperature on the motion of molecules. When temperature of solid or liquid or gas increases, what's going to happen is that the average kinetic energy of the molecules will increase. And this causes the average speed of the molecules to increase. So the molecules will move faster and more vigorously, and the average distance between the molecules will increase. The reverse is the same. When temperature decreases, the average Ke will decrease, the average speed of the molecules will decrease, the molecules will move slower and less vigorously, and the average distance between the molecules will decrease. Now, if let's say the question asks is in the context of a sealed container, or let's say a container of constant volume, then the average distance between the gas molecules will remain the same. Now, let's do some practice question. In this question, the figure shows how the temperature of a pure substance changes with time when it is heated at a constant rate. And it says that at point E, all the substance has changed to vapor. So let's look at this graph. So at point E, it has been changed to a vapor, which means at point E is a gas. That means D to E is boiling, C to D is just a liquid, B to C is melting, and A to B is a solid. Okay, so the question states what is happening to the substance between point B and C. So between point B and C, the substance is melting. Right? So you just have to answer the substance is melting between point B and C. Or you can also say thermal energy is being used to break the intermolecular forces of attraction. Both answers are accepted. You can write both if you want. Now, it is wrong to say that the substance is boiling or condensing, or that the substance is a liquid. These are wrong answers. Now, let's look at part B of this question. The movement and arrangement of the molecules depend on whether the substance is a solid, liquid, or gas. Describe the movement of the molecules of the substance at point A. So at point A, it is a solid. Now, you should identify whether the substance is a solid, liquid, or gas. Then you answer the question. So here, the substance was a solid at A, and the molecules will vibrate about fixed position. Now, you do not need to describe the arrangement of the molecules in a solid, so you do not have to say molecules in a solid are closely packed with regular arrangement. That is not needed in this question. Now, in part 2, the question asks for the arrangement of the molecules at a temperature of 50 degrees Celsius. At 50 degrees Celsius, the substance is a liquid. Then you describe the arrangement of the molecules in a liquid. So substance is a liquid. The molecules has irregular pattern or irregular arrangement, and they are packed close together. Or you can say that they are touching or very close together. Now, it is wrong to describe the movement of the molecules, so you do not need to say the molecules are sliding past each other. Now, it is wrong to simply just say the molecules are further apart than in solid. That is not accepted because the same applies for a gas. So you have to be very clear in your explanation. You have to say the molecules are touching or very close together. Now let's look at this question. Describe what happens to the molecules in water as the temperature rises. So when temperature rises, average Ke of molecules increases, average speed of molecules increases. So the molecules move faster and more vigorously. They slide past each other faster. The average distance between the molecules will increase. Now, it is wrong, and you will be penalized if you say that the molecules in water vibrate. or the molecules expand or become heavier, or the water becomes a gas. These are wrong answers, and students who write those will be penalized. In part B, by considering the molecules in ice and in water, suggest why the density of ice is less than the density of water. So to answer this question, you really have to focus on what is the meaning of density. So density in short is referring to the mass per unit volume, which actually refers to the number of molecules per unit volume. So the number of molecules per unit volume in ice is smaller because the density of ice is smaller than the molecules per unit volume in water. This means the molecules in ice are further apart than in water. Therefore, the density of ice is less than the density of water. Now, it is wrong to say the molecules in solid or in ice, they are closely packed compared to water. That is wrong. That doesn't apply here. Because this would imply the density of ice is more than the density of water, which contradicts this question.